Hi, second hour class. This is Mr. Assali. I'm obviously not in class, but I figured you'd get the next best thing because I know that you couldn't go a day without hearing my voice. So here it is. I did want to go over 12.2 notes with you guys, so you are still responsible for the homework in class, and whatever you do not finish is going to be due on Thursday. I know that it's a Thrives Day, so it's a little bit of a shorter day, so please make sure that you're actually working productively the entire time, and you were asked to bring a book with you for this reason. Um, so I'm going to go through 12.2, and I'm going to go through it a little briefly because we've already covered so much of this between lateral area and surface area. So you should be able to get the gist just from some general basic ideas. The first one is this whole notion of a prism that we've talked about before. But essentially what a prism has is it has two congruent faces. And those faces, we've referred to them as, so let me erase that here. These faces, and they are called bases. And if you remember, even when we did this before aims, I always said shade the two bases before you can get started with anything else because you have to know what your bases are before working any further. The other faces, so anything that's not a base, these are called lateral faces. All right, keep this word in mind. When you hear lateral in terms of lateral faces, that is anything that is not the base of the prism. Now, in terms of, for us, which are always going to be in the shape of a rectangle, and they could vary, they could be parallelograms, but for our sake, so I'm going to put a little star right there, they're always going to be rectangles. The altitude of a prism, which we've referred to it as the height, for our sake is the length of the lateral edges. And I know we're getting a little technical with definitions, but this does not change what we had written before. Beforehand, we always said it is the distance between the bases. That's why it was so important before that you would shade the bases. I know I keep saying to shade your freaking bases, but whether I'm here or not, that's never going to change. So it doesn't matter if this prism's standing up or leaning down. You're not really thinking of height in terms of vertical. You're thinking of height as the distance from one base to the other base. So if I'm looking at this specific prism, it's a right triangular prism. So I'm going to shade the two bases, which are the shape of a triangle. All the other faces, which would be this, this, and then technically the one on the back side of this, these are your lateral faces. Lateral faces. Because they're not the base. And then the last part of it is these lateral faces all meet. And where they meet, the part in blue, is called your lateral edge. Okay, so here we get a little more technical where we name the bases, and the bases are triangles. So it's going to be triangle SMI and triangle what? Good. PRA. I'm going to go PRA, sorry. Okay, now your lateral faces are rectangles, so we're just going to name them using the the four letters. So PAIM, ARSI, and PRSM. And then your lateral edges are going to be segments. So you have AI, which is the first one right here to the left, RS, and the last one's what? Colin. Good, PM. Nice job. So this is just identifying a little bit. We're going to skip this definition for right now because we're going to be all dealing with right prisms. What I did want to talk about is lateral area. Lateral area, think about lateral faces, is the sum of areas of the lateral faces. lateral, and surface area. We are talking about just the outside. I don't care about the inside of a 3D shape because that would be referred to as volume. We're just referring to the area of the outside faces. So this is basically all faces except the bases. So if you remember when we talked about surface area before, I said if I gave you a whole bunch of wrapping paper, how much wrapping paper do you need exactly to cover the entire thing up? Lateral area is a little bit different. It's if I gave you a whole bunch of wrapping paper, how much wrapping paper will you need to cover the outside faces and everything except the actual top or the bottom or the base of it? So the equation for lateral area is perimeter times the height. Now, if you remember when we talked about this before, anytime there's a capital letter, what does that refer to? Good. Capital letters always refer to the base of this prism. So the P stands for the perimeter of one base, and the H, let's draw a little arrow over here, stands for the height. Is that just the height of the base? No, of course not. Good job. It's not. It is the height of the entire prism. So from base to base, what is that height? Now, surface area, which we've done this before, we've done this several times. In fact, that 50-point test that we took a few weeks ago now, that dealt with surface area and volume. Surface area is everything. I want you to wrap the sides of the box, the top of the box, bottom of the box, or all different faces of the prism, lateral and the bases. So surface area is first. I want the area of everything around the sides, which is perimeter times the height, plus I want the area of the bases. Well, capital B stands for the area of one base, but how many bases are in a prism? Good job, Lily. There are two. So this is going to be pH plus 2b, and to refer to the B stands for the area of one base. Chris, stop talking. Okay. So let's go ahead and do an example to get a little more realistic view of what we're talking about. For the prism, find the. Before we do anything, what do you have to do to make sure that things are clear? You need to make sure that you are highlighting or shading. Well, I guess if you have highlighter, or shading the bases. So you need to make sure that both of your bases are shaded. Once we've done that, let's go ahead and talk about the area, lateral area, notice how it's LA, of a prism is the perimeter times the height. And it's the perimeter of what? Good, the perimeter of your base. So let's think about that. Here's the perimeter of your base. You have a 6 and an 8. Do I know what the third piece is? Not explicitly, right? But some of you guys are saying, yeah, you do know what it is. How would I know what it is? I'm telling you, I really think there are bugs coming from this pond next door. Okay, or maybe I'm just paranoid. Well, if this is 6 and 8, they're both divisible by 2. So I get a 4 here, a 3 here, which makes this a 5. But this actually ends up being a 10. So the perimeter is adding all of them up. 6 plus 8 plus 10. And that gives you your 24. Times the height of the entire prism, which is 12. 12 times 24 is 288, and our units were inches, and it's going to be good squared because it is area. Now to figure out the surface area, let's see what we have going on. Surface area equals the perimeter times the height plus 2 times the area of the base. Now perimeter and height, I could go back and figure out the perimeter of the base, the height of the prism, but we did all of this work right here. We already got 24 for the perimeter and 12 for the height, which gave us 288. Plus 2 times the area of the base. Let's think about the base here. What shape is the base? Your base is a right triangle. And how do I find the area of a right triangle? Good. 1/2 base times height. So here's 1/2 base times height. Now let's take a look at what I have. Plug and chug. Here's 2/2. How do I know which two segments are the base and height of the triangle? All right, they're the ones that are 90 degrees. So your base and height are the 6 and the 8. So I have 288 plus. You can multiply this in any way. Really doesn't matter. I'm going to multiply the 2 times the half because 2 times a half is just 1. So these will kind of cancel themselves out. And I'm left with 6 times 8, which is 48. So I have 288 plus 48. And that gives me a total of 336, units being inches. And since this is also area, it is going to be squared. Now, let's go ahead. Any questions, by the way? Questions? Questions? Good. Not that it really matters because I cannot answer them. So if you do have questions, that's good. Save those questions, and when you guys work together in with partners, if you are able to, while you're working on homework, hopefully you're able to help each other out. Now, let's move to the back side of this thing, and you should see a more familiar sight with the surface area and lateral area of cylinders. Now, cylinders are really ideal, and they were the easiest shapes for people to get because no matter what the height is, the bases of cylinders are always what shape? They are always circles, which makes it easy because the perimeter or circumference of a circle, that equation will always be set in stone. It's not going to change because the base shape will not change. So the lateral area of a prism was perimeter times height. Well, what is a perimeter called of a circle? Good, it's the circumference. And how do I find the circumference of a circle? 2 pi r. And then I have the h right there, so that has not changed. The surface area of a prism was perimeter height plus 2 times the area of the base. Well, we know that the perimeter height is 2 pi rh plus 2, that's your constant. What is the area of a triangle? What's the area, or not a triangle, I'm sorry. What's the area of a circle? Good, squared. Nice job, Brianna. Pi r squared. So this is a little easier because all you really have to do is just make sure you identify the radius and the height of the cylinder, and you're set to go. So let's see how easy these examples could be. The lateral area of a cylinder is 2 pi rh. So let's go through and plug and chug. 2 times pi. What's your radius? Good, radius is 5. The height is 8. Okay, so go ahead and multiply these out. What do you end up getting? You're left with 80 pi, good. And that is meters squared. Now let's take a look at the surface area. 2 pi rh plus 2 pi r squared. Do I need to do all the work for this first portion? No, because we just did all that. What did we get? 80 pi. Now, word of caution here, because you did all the work in lateral area, so you didn't have to do it again. But if you did not take your time and double check and make sure that you were careful, if you get lateral area wrong and you just plug it into surface area, guess what's going to happen? Exactly, so you have to make sure you're taking your time. 2 times pi, the radius is 5. That's squared. 5 squared is what? 25. 25 times 2 is 50. So when you combine those together, you get 130 pi, and it's meters squared. This should be enough to allow you to do your homework. By the way, please do not just give me an answer. I need to see work. I need to see which equation you set up and what numbers you plugged in for it. Make sure that you put your units in. And again, if you have any questions, please help each other and work together. Make sure that you're being productive. You guys usually are, so I appreciate it. But thank you again for working on this in class. And I will see you guys tomorrow so we're able to go through some questions if you have any. Yeah.